Alrighty, welcome back to our Math 20-1 playlist on quadratics. So this is that second lesson. The first one we spent basically, we factored everything we possibly could. We looked at a bunch of different techniques, especially the ones we saw in Math 10. And if you want some more specifics on those, again, I have Math 10 videos as well on the channel, so you can take a look at them, because they go way more in depth than what we did in the last one. So let's talk about what we can start to do once we've factored some things. And again, you'll find the links to all those resources that you'll need for this one in the description. So blank copy and the solutions, like always. So let's get into it. So a quadratic equation is where we'll go with this. And you know, the equation part really is going to tell you that you're going to have an equal sign now. Expressions don't have equal signs. So the equation has a term in the second degree and can be written as follows: ax squared plus bx plus c equals 0. That's the key. Your a cannot be 0. So if it is 0, here's the problem with that. There's something on my iPad here. Hang on. Okay. So if a was to be 0, right? For example, that would zero out the entirety of the first term. So you'd just be left with bx plus c equals to 0. Which is something you saw a lot of in Math 10, but it had a different format and a different name. We said that it was, one sec here, sneeze is coming on. We said that, you know, if it looks something like that, we had a linear equation that was mx plus b, right? Same sort of idea where we had something in the first degree. So if your a is 0, that means your square term is gone, no longer a quadratic. Okay, so a can't be 0 from here on out. Now we're used to solving an equation by isolating the variable. The problem here, you can't isolate it because there's an x squared term and an x term, and you know those can't be put together, right? They're not like terms anymore because the variables are different. They're in different powers. They have different degrees. So we can't add them up. But there is still a way that we can solve them. And there's 4 ways we're going to talk about in this course throughout this series of videos. Graphically is one of them. Factoring is another, and it's probably the most important way. We'll talk about roots and completing the square, and the quadratic formula as a last resort. But factoring is the one we're probably going to use the most of. And solving something by factoring depends on something called the zero product property. So if you assume that we talk about this example for just a second. If you assume that something like 2a is 0, right? 2 times a equals 0. So you can even write it as, right, 2 times a is equal to 0. What can you say about a? Well, if you think about solving this equation, you would divide both sides by 2. So a would have to be 0 for this to be true, and there's no other choice, right? As long as a is 0, this equation still holds true. But now there's going to be 2 variables. Right, 2 different things, right? What happens if it's a times b equals 0? Well, I know that if I multiply something by 0, I'm gonna get 0. So it doesn't matter if a is 0 or b is 0, one of them has to be. Both could be, but as long as one of them is, this equation is still true. So I know that at least one of a or b needs to be 0. Okay, it has to be. If it isn't, well, then this won't work, right? But as long as one of them is, this equation is still true. This property is what we're going to use along with factoring to solve some of these equations. Okay, so let's try out the first one. So solve the following, and it says to verify, so we can plug it back into check. And again, we're trying to find the value of x so that the equation is a true one. So there's my trinomial, x squared minus 2x minus 8. Factor it. I have to. It's such a crucial skill in this course that I have to be able to do it very, very quickly and know when to factor something. So if I'm going to be solving an equation that's equal to 0, you are going to factor it every single time. Okay, so if you find 2 numbers that multiply to -8, add to -2, those 2 numbers are x minus 4, and, well, x plus 2. Those are my two factors, right? So my numbers are minus 4 and positive 2. Well, now that it's factored, I have two things multiplying together to equal to 0. So if you think about this in terms of what we talked about 10 seconds ago, you could think about this as a times b equals 0. So one of them, either a or b, has to be 0. But I have factors and expressions in their place. So if I use those two ideas together, well, I know that x minus 4 has to be 0, or x plus 2 has to be 0. One of them has to be in order for this to be true. If I solve each of those little equations, I know that x could either be 4 or x could be negative 2, right? And if it is, those are the values that will zero out this equation. You can plug them in to check, right? So this is, we'll verify the first one, but we won't do all of them just for the sake of like the length of the video. So if my polynomial is x squared minus 2x minus 8, well, here's our verify. Well, let's say that x is 4, right? So let x equal to 4. Well, that means that 4 squared minus 2 multiplied by 4 minus 8 should be 0. 4 squared is 16. There's a minus 8. There's a minus 8 for 0, so this one works. Right? I know that if x is 4, that will zero out this equation. But if I do it for the other one, let x equal negative 2, well, I know that negative 2 gets squared. Minus 2 times negative 2 minus 8, again, should be equal to 0. So 4 plus 4 minus 8. And you can see again that there is a second value that makes this equation true. Right? Each of the factors gives us a value for x that makes it true. So factoring it is so crucial to be able to find the solutions to one of those equations. Okay, we can do that for b as well. The problem is we need it to be equal to 0 for this to work. Right? It has to be equal to 0, but right now it's equal to 3. So we're going to multiply everything out, collect some like terms, make it equal to 0 before we do anything else. Okay, before I even start to try this. So if you multiply things out, and I mean multiplying polynomials is also another skill that has to be, you have to be really, really good at it and very proficient at it because it all comes back and comes together in this unit. So if you multiply this out, you're going to get 4x squared plus 2x minus 3x minus 3. That's equal to 3. But we want it to be equal to 0, so let's move the 3 to the other side of the equal sign. So that 4x squared minus x minus 6 is now equal to 0. Why do I have 4x squared? That should be 2x squared. See, even I messed it up. So there we go. Right, so there is my 2x squared where it comes from, and then we get a 2x, then a minus 3x, and then a minus 3. So everything is accounted for, we're all good. Now I gotta factor this. Just like we talked about in the last video, find two numbers, multiply to negative 6, add to negative 1, negative 4, and 3 are gonna be your numbers. Okay, so a negative 4x and a positive 3x, and I can group those up together. Find your common factor of 2x to get you an x minus 2. Other one has a common factor of 3, again for an x minus 2. So that means I can fully factor this into being 2x plus 3 for one of them, x minus 2 for the other, and now it's equal to 0. Okay, so a little bit different than what we started with, but there's my two factors. If one of them is 0, the whole thing is 0, so I gotta find each of them independently. So 2x plus 3 should be equal to 0. That means 2x is equal to negative 3, which means x is equal to negative 3 over 2. And again, if you can't solve an equation, this is a Math 7 problem, right, from grade 7. So if you can't do that, then again, there's a whole other bunch of issues which cause a problem. If we solve the other one, well, that's x minus 2. Oops. X minus 2 equals to 0, so that means x is equal to positive 2. So there are my two places which will zero out this equation. Okay, and again, you can try to verify it. If you plug each of them back in, those are the values that will make this equation equal to 0 or equal to 3, right, depending on where you put it. Okay, C is no different. Again, you want it to be equal to 0 first, so let's collect all our terms on one side, so minus 12x, and that will leave you with 2x squared minus 12x plus 18 is equal to 0. Again, factor it. Look for a common factor first. I have one of 2, so there's x squared minus 6x plus 9 equal to 0. This is a perfect square polynomial, and I can tell because first term is x squared, so that's a perfect square. Last term is 9, square root is 3, so that's a perfect square. 3 times x is 3x, doubled gets me 6x. So I know it's a perfect square polynomial, and I can factor it quite quickly by doing those 2 square roots. So the square root of x squared is x, square root of 9 is 3, the sign in the middle of my x squared and x term goes in, and I have 2 of that factor, which is really like saying x minus 3, x minus 3. You can factor it by decomposition. You can factor it using the other method we talked about, finding 2 numbers that multiply to 9, add to negative 6. It'll be negative 3 anyways, so you'll just see them twice. There's a lot of different ways you can do this one. This is just the fastest. Now, since those factors are the same, I really only have to think about one of them. As long as x minus 3 is 0, that means the value that is the solution is when x is equal to 3. Right? It's the same solution that just happens twice. There's only one value here for it. Okay, so I'll leave the couple underneath here so you can try them out, and I'll have the full answer key waiting for you so you can compare how you did. Okay. Same thing for these ones as well. So I'll do B here because it's a little bit different than all the other ones, but A is very much so the same as all the other questions. So again, you'll find the answer key in the links there so you can double check. But let's do B. Okay, I've only got 2 terms here to think about, so I still want to make it equal to 0 first. So let's add 20x to both sides. And it doesn't matter which side you make 0 because you could just reverse it. This was just the way that my brain saw this. So 5x squared plus 20x to be equal to 0. So look for a common factor first. 5x is the greatest common factor that you could have. And then you've got x plus 4 that remains on the inside of that set of brackets. And remember that factors don't necessarily have to be binomials. They could be monomials, like this one is. So again, factors are things you can multiply together to get your original. This time I have 2 factors. One of them is 5x, so let's make that factor equal to 0. The other one's x plus 4. We'll make that one equal to 0 as well, and we'll find the 2 values of x that make this, equation true. So one of them, x has to be 0. The other one, if I subtract 4 from each side, well, I know x has to be equal to negative 4. Okay, so I've got my numbers, I've got my 2 values, I've got my solutions to this. Those are the 2 values of x that will make this true. And again, A you'll find in the key, which I'll post for you. It'll be in that link up above. Okay, one little application of this before we wrap this video up. So this is a short one because we did all the factoring stuff before. This is just one little extension on it. So you've got a rectangular garden. Dimensions are 5 by 7. Okay, that's in meters. When both dimensions are increased by the same length, the area of the garden increases by 45 meters squared. So our area is getting bigger. Determine the dimensions of the larger garden. All right. So let's just draw a picture here first. So it's a rectangle, right? That's one of the key words. Does it say actually, I don't think it. Oh, it does say rectangle. Second word in. Okay, so rectangular garden. The dimensions are 5 meters by 7 meters. My dimensions are increasing, so I'm going to have a larger rectangle. I just don't know how large quite yet. Oh, I did do that. Let's do this. There we go. So I don't exactly know what the numbers are, but that's what we're trying to figure out. When both dimensions are increased by the same length, the area increases by 45. So my new area is not 45, it's 45 more than my original. And if I know the dimensions of the original, well, the area is length times width, so my original one is 35 meters squared. So I know what my new area is now, because I could do 35 meters squared plus 45 meters squared, so that's how much I'm increasing by. My new area is 80 meters squared. Now I know my original dimensions were 7 meters, but I'm increasing it by some unknown amount. Let's call it x. I increase the width by the same value. So if my 5 meters gets increased by x as well, and I have all the information I need now to do this. If I know my new area is 80, right, I know my dimensions are 5 plus x and 7 plus x, I can find out what the new dimensions are supposed to be. So remember that the area of a rectangle is length times width. So if I do this in terms of the new rectangle information that I have, well, that means that my area is 80. That should be equal to my length of x plus 7, my width of x plus 5. Those get multiplied together, should give me 80. So let's do what we just talked about together. Let's make this equal to 0 in order to solve this. So we'll multiply out the right side here. So 80 equals x squared, that's going to be plus 12x's plus 35. So if we move everything to one side to make it 0, we can subtract 80 from the left side. That'll combine there. So we'll move this over to give us some more room here. So 0 equals x squared plus 12x minus 45. And again, it's equal to 0. There's my trinomial. Factoring is the most important thing you could do here. So break it up. Find two numbers that multiply to negative 45, add to 12, and you'll find it works out to be a positive 15 and a minus 3. So I've got my trinomial factored. I've got the two that will make it 0 when you multiply. So let's find the specific value of x for each of them. So x plus 15 could be 0, or x minus 3 could be 0. So x is going to be negative 15. That's one of them. Or x is going to be positive 3. But the problem is, this is an application of this, right? There's a context applied. It's a word problem. I can't really have two different solutions for this if I think about it, because one of them's negative. And if I think about this actually having applications to a rectangle, if I go to find the dimensions, so if x is going to be equal to negative 15, well, that means the width is supposed to be 5 plus x, which is really 5 plus negative 15, for a width of negative 10. That doesn't make sense, right? So that can't happen. So I know that x can't be negative 15 according to my context. Okay, so that answer's out. I can't use that one. But if x is equal to 3, well, then the width is supposed to be 5 plus x, which is 5 plus 3 for 8, right? So 8 meters is my new width. The length has new dimensions also. It's 7 plus x, which is 7 plus 3, which is also 10 meters. So I've got my new dimensions, width of 8, a length of 10, and it does make my area work out as well, because length times width is area, 10 times 8 is 80. So I know that this one works out also. So factoring has huge, huge implications for this unit. The better at factoring you are, the easier this unit is. If factoring is a problem, well, that was literally the first step in solving this question. So if I can't factor, everything else kind of falls apart also. So if you need that factoring practice, again, look back at some of the other videos, find some resources online. You can literally search up factoring practice. Khan Academy is another good place to do that. And there are a lot of resources available online to do that. So I hope that was okay. It's a little bit of a shorter video because of how long the last one was. When we come back in the third video in this series, we'll talk about like how to graph these and what the graphs are going to tell us, how to solve them. So take a look for that one. Again, it'll be linked up above. Probably right now it'll show up. So you can find that there as well. So we'll see you next time. So enjoy the rest of your day, wherever that takes you. Take care.